Okay, so here we're going to take a look at Charles' law and some of the practice problems. When you find your quiz, you'll notice up at the top, the formula is given to you. Like a tool, you got to know how to use this though, right? So this tells me that the starting volume over the starting temp, or V1 over T1, is going to be equal to the ending volume and the ending temp. And notice that the ratio should be the same. We also discussed in the lecture that this is a proportional relationship, which basically just means that if one of these goes up, the other goes up, or if one goes down, the other goes down. So even though we don't see it up here, hopefully you kind of recall that from our gas laws, pressure is going to be our constant in this. We're going to assume that that's held in check, and what happens when volume and temps are manipulated. So the example that I always go back to for this is that balloon in the freezer. You might remember that kid took the balloon and it had a volume and they put it in the freezer. So obviously the temperature went down, and then what we saw was that the volume went down. Or as the temperature, motion, went down, the volume, space, went down. And then they took the balloon out, it warmed up, temperature went up, which is to say those particles were moving faster, so it occupied more space, or it expanded. So here's how I would go about trying to solve these. I know if we're doing anything with Charles' law, I got to account for the starting volume and the starting temp and the ending volume and the ending temp. And I got to get 3 of those 4 pulled out of the problem. And then I can always solve for the other. So if I got V1, T1, these are locked together. In other words, whatever your starting volume and starting temp is, they got to go into these specific spots. I can't just randomly assign numbers to any old location and then plug it into the formula and hope for the best. It's got to be matched up in the right spot. And I like to think of this as matching rather than mathematics. So there's my beginning variables. And then I got V2, T2. And I got to find these guys here. So if we just take a look at number 1, I don't like to read through all this and then just try to pull out stuff. I like to read through it and then have it nice and organized. If this works for you, I think you'll find that it kind of decreases your chance of making some boo-boos. So I got, if a balloon in my fridge that initially, fancy word for starts, has a temp of 22 degrees Celsius. So this is like where my starting temperature has to go. And a volume of 0.5 liters. So it sounds like that was the volume at that temperature. What will be the volume? So obviously then I'm solving for volume. I'm just going to call that X when it's fully cooled to 4 degrees Celsius. So before I move any further, I know that when I plug this stuff into our formula, it's got to be converted into Celsius. And I'm taking a look at this, and maybe I reread through this just to make sure I didn't mess anything up or put things in the wrong spots, and I can kind of move this up. But I'm going to do my conversion into Kelvin right now. So you don't have to memorize this. It'll be at the top of your quiz, but I add 273 here, and I add 273 here. So if I got 22 plus 273, that should give me 295 Kelvin. And a lot of times I'll even go back, scribble this stuff out just so I don't mess up and plug in something from there in the formula. I got 4 degrees Celsius plus 273. So that should be 277 Kelvin. Don't want to use any of those. So now I got to match this stuff up, right? So if my formula is V1 over T1 equals V2 over T2, V1, V1. I mean, this has to go here, top left. If I just randomly assign things and hope for the best, it's probably not going to work out real well. So I'm going to go 0.5 over 295 equals, I was solving for this, my V2, over 277. And from here, I can cross multiply. But before I do that, I'm going to take a look at my numbers here and just kind of guesstimate what I should wind up with. So it looks like my T went from 295 to 277. So the temperature cooled. And I know that means that if the temperature went down, the motion went down, that my space should go down. So I should get a number that's less than 0.5. That's what I'm expecting. So let's kind of try to figure this out and make sure I don't make any mistakes. I got 295x equals, I got to use my calculator for this. So I go 0.5 times 277. And I wound up with 138.5. Now I got to solve for x. So I divide this guy out by 295. Divide this guy out by 295. So I'm going to go back to my calculator. Divided by 295 equals, and I got that. So I usually look at hundredths. Should I round that? I'd call this 0.47. If you want to write all that out, feel free. But I'm going to just say 0.47. I was solving for volume, or that ending volume, my V2. So I know the unit has to be liters. And now I can kind of take a look at this and say, all right, volume went down a little bit, temp went down a little bit, seems reasonable. If you want to, you can actually go back and double check to make sure you're right. So if I plug in 0.47 here and divide this out, so if I go 0.47 divided by 277, I got this number. 0.001697. So if I divide this, I should get the same thing because these ratios are proportional, right? So I go clear 0.5 divided by 295 divided by 295, and I got 0.00169. Cool. Everything looks legit. I'm happy with that. I feel like I did things good. I can move on, and I know I did that problem right. If you got questions, see me before or after school or SST. Thanks.